Okay, now that you've answered the two just basic questions to start getting your brain thinking about science and labs. Now I'm going to take you through the actual steps of the scientific method. So, as I said before, the method that scientists use to do science and that we're going to use to do our labs is called the scientific method. And I'm sure many of you have heard of it before. But basically, this is how all scientists work. So, you're going to use this method in middle school and high school and beyond. Sometimes I even use this method to solve my own problems or even to find like those darn keys. I always have a problem where I throw my keys wherever when I come in at home, and a lot of times I lose them. So sometimes I even have to use a problem solving step. That is very much like science in my daily life. But let's talk about this. So this is called the scientific method. And it's something that all scientists use. And there's basic steps. There's 5 basic steps. Okay. And the very first one that we think of is we kind of identify what the purpose is or the problem. So we might ask a question. Then we form a hypothesis. We say, I wonder what I think is going to happen. Then we actually do the experiment. Then we record or analyze and write down the data, the results, and then we kind of come to an aha moment. We draw a conclusion about what we've done. So I'm going to take you through some of the steps today. Okay, so just continue to watch the video. So on your screen, you'll notice a couple charts, and this just takes you through what I asked you. You've probably seen this before, what I told you about, where the scientific method starts with asking a question. It includes making some observations, making a hypothesis or a guess, and then testing and analyzing our results. And then based on what happens in the end, we can share those results or not share those results, go back. There's all sorts of different stuff that we can do, okay? So this is an example that you can look at later. That's the steps of the scientific method. But as you notice, the same kind of things are coming up. An observation, a question, hypothesis, results, and then a final conclusion about what we thought happened, okay? I also think this person has a very interesting, very tiny head. That's kind of fun to laugh at. Okay, so let's start with the very first step of the scientific method, and that's identifying the purpose, okay? Or as my brother says, the purpose, okay? The purpose is to identify why you're doing the lab. So why the heck are you doing a lab on this topic? Okay, so why do you want to know the answer to that question? So here's an example. A purpose could be maybe I thought about, some of the plants that I have in my yard are growing at different rates. And maybe I don't think it's because it's the sunlight or it's the rain because I'm giving them the same amount. So I kind of want to just test and wonder, is it possibly, could it be different music that makes them grow different amounts? And so that's what I decide my purpose is. So I kind of come up with a question and I say, do plants grow differently with different types of music playing in the background? And then I think about the different types like rap and country and classical and rock. But that's my purpose, is I want to know, would plants in a lab actually grow differently, like whether I was giving one classical music or one rap music or one country music? Would they grow at different rates? Maybe plants actually have preferences for music. So I always start out with a purpose, a starting idea or thought. Okay? Then I move to a hypothesis. And a hypothesis is basically just a fancy word for a guess. It's a prediction on what I think will happen in a lab or an experiment. And the best thing about this is that it's a guess. So it could totally be wrong. You're just kind of thinking about what you think might happen. And the two magic words that always come in a hypothesis are if and then. So I always have to word it in a very sophisticated way. So let's say I thought country music, yeehaw, would get plants to grow the tallest. Well, then I would say my hypothesis would be something like this. If plants listen to country music, then they will grow taller than plants that listen to other music. That's what my guess is going to be. And again, I could really guess anything I want. It's just kind of based on my own opinion and maybe my own observations or thoughts. So we start with the purpose. We then make a guess called a hypothesis. Then the next thing we do is a procedure. This is where we show the steps or go through the steps of the lab, okay? And this usually tells us the materials we use and the steps we took. So a lot of times in drawings, or usually more often with what's called a procedure, we see in steps of how a lab goes. So it might say, it kind of looks a lot like a recipe, like if you're cooking. So it might say, number 1, pour 8 cups of soil mixture into each plant pot. So I know I have to do that first. Then number 2, plant 5 seeds into each pot, spacing them evenly apart. and then 3, and so forth. And it would just be the list of the steps that I do. And these are really, really important because if everybody's doing the steps the same way, the lab is supposed to generally happen and come out with the same results. So it's good to have a really precise, specific procedure. Just like if you're making a batch of cookies and you want them to turn out right, you got to have the right ingredients and the right steps, right? Okay, after we do our experiment, so here's an example. Like maybe I would set it up and I would say, okay, during my experiment, here's what I'm going to do. I'm going to grow these plants and I'm going to have the certain pots and soil that are all the same. I'm going to put them in the same conditions, like I'm going to expose them all to the same sunlight, all to the same amount of water. But in one room, I'm going to blast the country for a couple hours a day. In another room, I'm going to blast the rock and roll. In another room, I'm going to blast the classical. And another, I'm going to blast the rap. And for the same amount of days, these plants are getting exposed. And that's what this would say in my procedures. I would basically explain what's happening. Okay? And I would do that for a couple days and I'd watch it grow. The next step after my experiment, so here we go. During my experiment, I would watch, observe, and record what happened. So I would decide on a certain amount of time. It would have to be the same for all these, right? Like if I said I want to grow the plants for 2 weeks, I'd have to do it for country, rock, classical, and rap. Okay? Then what I would do is I would make some kind of chart. So the next step would be to look at the evidence. So maybe I'd make a graph or a chart about how much the plants had actually grown. And if you look here, there's charts, there's bar graphs and pie graphs, all sorts of ways to visually show how my plants did. So maybe I find out that, hey, they didn't grow as well with country and maybe they grew the best with rap. I would want to create some kind of chart that would show my results, right? And then in the very end, I put all that information together. So now that I've done the lab, now that I've looked at the results, I might actually go back and look at my report and say, whoa, like if I was looking at this pie chart, this green one had a ton of like almost half, right? So I would know that that would probably show me that the green one was the one that worked the best, or that would give me my answer, right? So maybe if green represented classical music, maybe I would say, whoa, the plants grew that much taller with classical music. That would be my conclusion. And I would have to talk about how the plants with classical music grew the tallest and why I think that might have happened. Okay, so I make a conclusion, a final statement. And what's great about the conclusion is you restate what you were trying to do, you summarize what happened, and then you also talk about any of the errors you might have made. We're all human, we make mistakes. So what's really nice about the conclusion is we can also talk about any errors or mistakes that we made during the lab that might have changed our results. Okay? So here's what you're going to do. You have 2 more slides, y'all. We are going to go to the next slide. And all you have to do, and you can go back and look at the slides you have or listen to my presentation, but I want you to simply put the steps of the scientific method in order. Okay, and you're going to do that by clicking on one. So let's say I think the hypothesis is the first step. Okay, so what I'm going to do is I'm going to click on the word hypothesis. This box will open. Then I'm going to take this box, look for this cross sign, and I'm going to drag it up to the first step. Okay, and I can just kind of get it right around there. So I think that's the hypothesis. Then I'm going to click somewhere in the white. Then I think evidence is the second one. So I'm going to click on evidence, and I'm going to move the box over so I can see evidence. Okay, and I'm going to put these steps in order. Hint, hint, the hypothesis and evidence are not the first and second step, okay? So go back and change my work, okay? All right, the last slide you're then going to do is pretty easy, but you can see that all the steps are in order. So you got the purpose, hypothesis, procedure, evidence, conclusion. Now what I want you to do is draw a line from that dot to the description that talks about that, okay? So for example, the conclusion is kind of the last thing you do, right? It's where you summarize in the lab. So if I read all these and look at them, I see, oh, the final summary of lab results is right here. So I'm going to draw an arrow from conclusion to this box, okay? So I'm going to do that by going up here where it says arrow. I'm going to click on arrow. Okay, then I'll see this little plus sign here, and I'm going to draw one by pressing down on the mouse from conclusion to the final summary results, and I'm going to make my arrow. Okay, then I have to click out of the white, and I'm going to go back to line, pick another line or arrow, and draw another one. And I'm going to try to get all the lines going to the right spot. Okay? Then if you want, there's fun little videos to watch about scientists who actually did try to see what music worked best, because it's actually an experiment. And then in the end, when you're done with all that stuff, make sure you finish slides 2, 3, 14, and 15 and turn it on in, and have a great day, guys.